Hi, this is Shirisha. PMI, PMI0, and PPMI from sparse co-occurrence matrices. In this project, I extended the co-occurrence matrix builder to implement different word association measures directly on sparse matrices. The main goal was to understand how PMI, PMI0, PPMI, and smooth PPMI change the relationships between words compared with simple raw co-occurrence counts. This project covers starting with this password into context co-occurrence matrix, computing PMI point-wise mutual information in sparse form, computing PMI0 while correctly handling zero count word context pairs, computing PPMI positive point-wise mutual information, computing PPMI with context distribution smoothing, using the smoothing exponent, performing all calculations without creating a dense V cross V matrix, comparing raw counts with the PMI or PPMI based associations, measuring matrix sparsity, plotting histograms of raw counts, PMI 0 values, PPMI values, finding the top 10 context for selected query words, comparing ranking based on raw co-occurrence count, PPMI, smooth PPMI, studying the effect of stop words on word associations. Handling count is equal 0 when count w comma c is equal 0. The PMI value is mathematically undefined because log 0 is undefined. Therefore, zero count entries are not explicitly metallized in the sparse matrix. Their PPMI contribution is treated as 0. This approach allows the entire computation to remain sparse and avoids the huge memory cost of constructing a dense vocabulary by vocabulary matrix. PMI versus PPMI. PMI measures how strongly a word and context are associated compared with what would be expected from their individual frequencies. PPMI keeps only positive PMI values. PPMI W, C is equals to max of PMI W, C, 0. Therefore, negative associations are removed and only positively associated word context pairs remain. Raw frequency tends to favor very common words, especially stop words. PPMA reduces this effect by considering how frequently a word context pair occurs relative to their overall frequencies. As a result, PPMI can identify more meaningful contexts instead of simply selecting the most frequent words. Stop words such as common grammatical words can occur with many different words. Because of their high frequency, they can dominate the raw co-occurrence rankings. PPMI generally downweights these common contexts and promote more informative words. The experiment also applies context distribution smoothing. This reduces the dominance of extremely frequent context words while still retaining their influence. The top 10 context lists are then compared before and after smoothing to determine whether the ranking changes. The project reports here is matrix shape, number of non-zero elements, sparsity or density, raw count distribution, PMI0 distribution, PPMI distribution, top 10 contexts by raw count, top 10 contexts by PPMI, top 10 contexts by smooth PPMI, effect of stop words, effect of context distribution, smoothing. PMI can give very high scores to rare word context pairs. Therefore, very low frequency events can sometimes receive disproportionately high PMI values. This is one reason why minimum count filtering, PPMI, and smoothing are useful when building practical distributional and representations. Thank you.